Hi everyone, welcome back to XCA, Xcoding with Alvian. In this video, we're going to build a WhatsApp sticker maker iOS application. We'll use the new iOS 17 Vision Subject Lifting API. This API can basically be used to remove background in an image containing foreground objects, whether single or multiple, person, animal, food, shoes, etc. With the background removed from the subject, we can simply export the image as WhatsApp sticker. This app makes it very easy to create sticker packs which you can use in chat with your friends or family. Okay, so let me show you the demo of the application using my iPhone. So here we have the main view. It shows a grid containing 30 items plus one item for try icon. So we can export maximum of 30 stickers and one try icon. So the try icon is required for WhatsApp. To add an image, we simply tap on the grid item like this. It will open the photo figure, and then we can simply select the image that we want to add, like so. Okay, as you can see, it added the selected item and the background is also removed as well. We can also toggle whether to show the background or not for previewing purpose. Okay, using this show original toggle. Nice, right? To export stickers to WhatsApp, we simply tap on this export button at the navigation bar. Okay, so it's going to show this preview containing the stickers, and there's an option to save this. So let me click save. So we can simply select the sticker by tapping here, and there you go. We have our sticker there. So I can just use my sticker. Nice. Okay, so this is basically the app that we are going to create. Basically a WhatsApp sticker maker application. That's it for the demo of the application. Now let me close this QuickTime mirroring from my iPhone. So before we begin, make sure you have installed Xcode 15. We won't be able to remove the background using the iOS simulator, as currently it doesn't support Vision Subject Lifting API requests. So if you don't have physical iOS device and you have Apple Silicon device, you can also use enable Mac Catalyst support for previewing the background removal. But in this case, we won't be able to export to WhatsApp if you use Mac OS Catalyst. So if you have iPhone physical device, that will be the best option to continue. Okay, but remember, if you just want to try the background removal, we can use the Mac Catalyst built-in preview. Okay, let's begin by creating a new Xcode project. So here, select iOS, select app, click next, give it a name, any name that you want. I'm going to give the name of XCA sticker maker. Okay, provide your organization identifier, bundle identifier. Make sure to select SwiftUI as the interface and Swift as the language. For storage, just select none and you can uncheck include tasks. Click next. Save it anywhere you want. Okay. Okay, now we have created the new application. So the first thing that we want to do is to navigate to the project settings. And first we need to modify the info plist. We need to add a new key. So right click, add row, and then type privacy and photo library editions usage description. Okay, as we are going to use the photo picker from SwiftUI to access the user's photo library, we need this permission. Okay, select photo to convert to sticker. Okay, so provide the message that you want to show to the user. And the second key Click again add row, and now select this queried URL schemes, enter. So this expects an array of items. So here for the first item, we only need one item. For this, we need to add WhatsApp. Okay, so we are going to basically open the WhatsApp URL, and basically with this we should be able to ask UI application whether we can open WhatsApp or not. Okay, in case the WhatsApp is not installed in user iPhone. Okay, we have set up the project. Next thing is I want to also add a Mac Catalyst support to this app, so it can help us to preview the background removal. So select this plus here and select Mac Catalyst. Okay, click enable. And now we should have Mac Catalyst to preview the app. Okay. And I should remember that we won't be able to use the background removal vision API in iOS simulator. Okay, but we will be able to use it using Mac Catalyst. And next thing is I want to set this to only have portrait orientation for the iPhone. And before we begin, I just want to add one sample image to help us previewing the image container view that we are going to create next. So I'm going to add this basset.jpg. You can add any image that you want to help us previewing, okay, when we create the view. Okay, let's make this bigger. And now I'm going to change this to my Mac Catalyst. It should be able to also have the window here. So any change that we make in here, hello XA, will be reflected in this preview. That's it for our initial project setup. Next, let's create the image container view to display the image. Okay, select SwiftUI view and give it a name of image container view. So let me declare several constant with CG float. Let me set it to 108. So this will be the width and height of the grid item. It will have the same width and height, so it will be square. Okay, also spacing between the grid item, just declare it here 20. And next, let's declare several vars. First one is batch text. We will show this at the top left of this image container. So this will be showing the number of the sticker. Okay, 1 to 30. Okay, so this will be optional. Next one is also the image that will be shown. Will also be optional. Okay, and now let's declare let me just resize this, a C-stack with the alignment of top leading. Okay, so first let's check if the image is nil. In this case, we're going to show SF symbol photo.batch.plus. This will be a visual key for the user to add an image to tap this. Set the image scale to large and set the foreground style to color.accent color. Set the frame max width to infinity, max height to infinity. Okay, so for this C stack, actually I want to set the frame here explicitly with, I'm going to use the constant that we declare at the top. Okay, it's going to be a square, same value. And let's add an overlay, a rounded corner, rounded rectangle with the corner radius of 810. And let's add a stroke. We're going to use stroke color.accent color, and for the style Let's set the stroke style with the line width of 3 and dashed to 8. Okay, so let's see the preview. So need to move this window here. Okay, so this is the preview. So we have this SF symbol image, photo.batch.plus, and this overlay containing the round rectangle with the stroke of this line width of 3 and dash of 8. Looks good, right? Next, we're going to continue inside the C stack. So if we have the image, we're going to just display it, but we need to resize it to fit the container, and then evoke scale to fit. And let's clip this and add a frame with the max width of infinity and max height dot infinity. This will basically fill the width and height of the container. Okay, it will have the same width and height. Next one, if we have the batch tag string, we're going to basically show the batch text string using the text, and set the font to caption, set the foreground style to white, and add a padding of 4 to all the edges, and set a background using this closure. I'm going to use a circle in here with the foreground style of color dot accent color. Let's add a additional padding again, in this case only the leading edges and the top. Okay, put it in an array with the value of 8. So in the preview, let's add a VStack. So this will be empty, and this one is, let's get to preview batch text. So let's say 12, and the image, let's use the image that I have provided in here, which is this best town image. Okay, Basset. Okay, this is the Basset image, just to have us preview this. Maybe this is incorrect. I need to put this inside the asset catalog. Give me 1 second. Let me just put this in the asset catalog instead. Okay. Okay, let's try again. Bring forward. Okay, I think this sure works now. Okay, we have the dataset in here, as well as this batch text 12 with the text of 12. Nice, right? So yeah, we have implemented the image container view successfully. Okay, so next let's implement the wrapper for the SwiftUI photo speaker. Basically, in this review wrapper, we're going to add a mechanism where the user can provide a closure, and then we'll pass the CI image to the user after they select an image. Okay, so basically the view that uses this wrapper view to select the photo should be able to process the CI image after the user select, because we are going to play around using the CI image for the vision subject lifting API. So let's do it now. So just create a new SwiftUI view again. Give it a name of image picker. So first let's import core image.ci image. Okay, and then let's import SwiftUI is already imported, and photos UI, and also UI kit. Okay, the first thing we're going to do, we're going to add a generic to this label. Okay, and view where the label also is a view. Okay, with this we should be able to provide the one that uses this image picker should be able to provide their own view. Okay, now let's create a state private var in here image selection, which is photos Fiker item. The initial value is nil. Next one is let's add a label in here. It's just a closure that will return a label. This will be provided by the parent view. Okay. And next one is also the closure on selected image. So we will invoke this after we load the transferable data into the CI image. So it can be processed by the parent view as well. Okay, looks good. Now let's implement the body in here. We can simply declare the photos picker selection as part of binding of image selection matching. We only want to match the images, okay, all the images in the photo album. And then here we're going to invoke this label. Okay, so this will be the view that will be shown and the user can tap. In this case it will be the image content view that we have created before. Okay, now let's create a private function load input image from photos figure item. Okay, the type is photo figure item. This should be optional. And then in here let's add this on change of, in this case in image selection we're going to basically pass this closure. We only want the new selection, so there are two parameters, the previous and the new. In this case we're going to just invoke self.load input image passing the new selection. So the selections itself won't be the actual image, so we need to basically convert this ourselves to CI image. Okay, so for the preview we can simply pass anything that we want in here. Okay, label, maybe text, select photo, and then image in, I don't know, we're not going to process the image in the preview. Okay, that's the preview. Now let's implement the load input image. In here first we need to check where the item is not nil using the gotlet. Because it is nil, you just return. And continuing on we're going to invoke the item load transferable. Okay, in this case this one we want to check the type to be data.self. Okay, and in the result completion handler we just use the switch on the result itself, and in case it is failure we grab the error and then just print it, fail to load. Okay, error using string interpolation and just return. Okay, next case is success. Grab the data. So this is actually optional. We need to use gotlet data. So if this is nil, fail to load image data, and then just return. Then again got var here. So now we need to convert this data to CI image. Guard var image can simply use CI image data initializer passing the data. Else we can just print fail to create image from selected photo. Return. So you might be wondering why I'm using var in here. So actually if we select image from the camera, the rotation we need to basically fix that because it will be on landscape. Okay, so we need to check basically at this check if at orientation image properties, it will have this key orientation. We need to cast this as in 32. and we need to check if the orientation is not equal 1. 1 is means it's a portrait, right? If it is not equal to portrait, we need to basically invoke image, and then we need to invoke this oriented for EXIF orientation, passing the original orientation. Okay, this will make the image to be portrait. Okay, because we don't want to display a landscape image right in our grid item. It will be very weird. Okay, now we can simply invoke dispatch queue .main.async and invoke the closure on selected image, passing the CI image. Okay, everything looks good. Now we should be able to use this image picker to select image from the user photo library. Nice. Okay, so before we continue, let's first create a helper class. Okay, create a C file, give the name of ImageVision helper. So in here, first we just need to import core image. Okay, and let's give it a name of ImageVision helper. So basically here we create a func render CI image EMG CI image. So given an input of CI image, we're going to convert it to CG image. Okay, so let's just use guard let's CI image, and then we're going to use CI context, passing options of nil. Okay, and then we're going to use this create CG image from. So we're going to pass the CI image, and from the rectangle we're going to pass emg dot extend, so it's a CG rect. So else in here, let's just print fatal error. I think I never encounter actually the case where it's nil. Okay, but if you want to be careful, you can also make this as an optional and return nil. Okay, but for the simplicity of this tutorial, let's just make this fatal error. Okay, and don't make this optional. Now let's go to the content view, and let's remove this body. And now let's declare stat var image, make this optional. So in the body, let's declare the image picker. Okay, using this label. So in the label, we need to provide the view, which is the image container view. For the batch tags, let's pass just our coded IC, and for the image, let's pass the state. So on the selected image, in here we simply set the self.image, the state, by initializing the SwiftUI image. So in here we're going to initialize an UI image from the CG image, and we are going to use that ImageVision helper dot render, passing the CI image from the image picker that we select. Okay, now let's try this. A bit complicated on the transformation of all this SwiftUI image, CI image, UI image, CG image, but that's how it is. Okay, so let me bring forward the preview. We should be able to select and the photo. Okay, nice. It's opened the photo picker in the macOS using the catalyst. So now I can simply select one of the photo in here. So let me select this one. Nice. As you can see, my photo is being shown in here. You can also change if you want to other image. Okay, guys, that's it for the image picker. Now we are certainly sure that this image picker works without any issue. Now we will move to implement the background removal. Okay, now let's go back to the image fusion helper to add this method. So let's declare func remove background from image. So it's going to be ci image, and then we're going to pass this crop to instance extend. Okay, so I will explain this a bit later after we implement this. Okay, ci image. In this case, the image will be optional. Okay, remember that on simulator this fusion request can fail, right? Because it doesn't support that on the simulator environment. Okay, the first thing that we are going to do is, first one is we need to import fusion. Okay, fusion framework, and then in here first let's declare a constant request. So we need to basically initialize vn generate foreground instance mask request, a request that generates an instance mask of noticeable objects to separate from the background. Okay, this one. Okay, a bit complicated for the name. Let handler, and here we need to initialize vn image request handler, an object that processes one or more image analysis requests pertaining to a single image. Okay, so in here we need to pass the image. So let's pass the ci image. Okay, now we have the request and the handler. Next, let's create a do try catch. In the catch, we just print failed to perform fusion request, and we simply return nil. And in the do, we can invoke handler, this image request handler, and then invoke perform request. Okay, so this request itself is an array. We need to pass the request that we want to perform for the analysis. In this case, we pass our request let, which is the foreground instance mask request. Okay, to be processed and analyzed. Okay, so if there is no error thrown, we will simply continue and just the guard let result, and to grab the results we use these results. So it's an array vn instance mask observation, so we just grab the first one, else we return nil with this empty. Okay, no subject observations found. Okay, this code itself is from the Apple WWDC 2023 sample code. Okay, for your reference, but I made some modification to make this simpler. Okay, so next one, let's clear the do try catch again, and here in the catch block just print fail to generate masked image. Okay, and return nil. Okay, so for the name of this, I think I made a mistake. This should be result. Okay, not request, result, guard let result. So basically in this result vn instance mask observation, there are two methods that you can use. First one is generate scaled mask for image. So this will return a high-res mask with the selected instance per serve. Okay, while everything else is removed to transparent black. And next one is this generate mask image of instance. This is the high-res image with everything, but the selected instance removed to transparent black. So this is the one that we want to use. So with the generate mask image, we can pass the crop to instance extent. So basically it will zoom in to the only subject that getting lifted. Okay, so if you want to use this scaled mask image, you can actually get the mask, the actual scaled mask, and you can play around with that scaled mask, maybe using the ci filter to create a composition to basically provide the input image, which is the original image, apply the scaled mask, and then you can also apply several filter that is available from the ci filter. For that, you can check the Apple WWDC 2023 sample code. I will provide that link to that sample code in description. But for our use case, which is to create the sticker, we will use this generate mask image. Okay, so in the do, we can simply declare let masked image, try result, Okay, there is a throwing, it's going to be a throwing method. So we use this one, generate mask image of instances. In this case, we just pass all instances from the handler and the crop into instance action, whether we want to basically zoom into the subject that getting lifted. Okay, in this case, we want to pass it based on the parameter, but when we call this letter, we will pass through. Okay, now we can simply, so this mask image itself, it's a CV pixel buffer. Okay, so we need to convert it to CI image by just initializing CI image using this CV pixel buffer and passing this mask image. Okay, now we have implemented this remove background. Okay, a bit complicated, but this is the implementation. Now let's try to test this quickly in the content view. Okay, so in here, let me just quickly replace this. So we going to have a state of input image as well of the state var output image, and we are going to have a toggle var show bg to false. So there will be a toggle that we will use to show the input and output image based on this boolean value. Now let's create an edge tag in here, and let's move this image picker inside this edge tag. Okay, so beside this edge tag, let's declare toggle. With this is on, we just pass show bg in the label text show background. Okay, in the image container view, we're just basically going to use the ternary. So if the show bg is true, we're going to show the input image with the background. Otherwise, we're going to show the output image with the removed background. Okay, on the selected image, we simply need to initialize the image vision helper. In here, first let's declare input image. This will be UI image. First, we need to convert this CA image first from the completion closure using image helper.render, passing the image from the completion closure. Okay, next one, let's declare an output CI image. Here we can simply invoke image helper.remove background. Okay, from it's expecting a CI image, we can simply pass the image from this completion closure. Crop to instant actions is true. Let's just force unwrap this for now. Okay, and then in here, let's set the declare an output image using UI image CG image. Okay, again we are going to ask the image helper to render the CI image from the output CI image. Okay, now we have the input image and output image both on using both our UI image. We can simply self.input image, input image, UI image, input image, right? And self output image, image UI image, passing the output image, right? Okay, now let's try this, bring forward. Okay, I'm not sure why the scale of this is quite small, but hope you're able to see this. Now let me select one image. Let me select this one. Nice, as you can see, it's being added and the background is removed. Now let me toggle this, show background. Nice, it showed the original input image containing the background. Okay, so you remember that crop to instant actions, right? So if you see when the image is being lifted from the original background, as you can see it's getting zoom in, right? So that's why, so that's how the crop to instant action true works. Okay, it's going to crop that image when it's getting lifted from the subject. Okay, that's it for this. Now let's move on to implement the actual UI and view model. Okay, now let's create a new Swift file for our view model. Just give it a name of view model. Okay, let's import observation, and let's also import SwiftUI, core image, and UI kit as well. Okay, so before we create the view model, we'll have declare several enum as well as struct to represent the model of our application, in this case the sticker and the image data. Okay, so first one is the enum sticker state. Okay, so there will be two state for the sticker state. First one is none, in case it is not yet selected. Second one is selected, so we will have an associated value of image data. Let's just create a struct of image data. So for the image data, we're going to have three var here: input CI image, this is the type of CI image, and input image, this will be UI image, and output image, this will be UI image optional. Okay, so there we have the enum and struct. Now let's just declare the third struct, which is the sticker itself. Okay, a representation of WhatsApp sticker. So in here, let's just create this UID to conform to the identity variable. And next one, let's create a box post, which is an integer to determine the position of the sticker. Okay, so let's assign the default value of 0. And next one is a state. Let's just assign the state sticker state of none for the initial value, default value. Next one, we need to also add this boolean try icon to determine whether this is a try icon sticker or not. Okay, default value is false, it's not a try icon sticker. Next one, let's declare and just compute var for the image data. Okay, in this case we can just use if case selected, and we can simply return the image data. It's not, it's nil, just return nil. Okay, continuing on, just input image, it's going to be a SwiftUI image. We can simply use guard let image data, else return nil. And now we can simply initialize SwiftUI image using UI image passing image data dot input image. Remember that the input image is not optional for the image data. Okay, next one is the output image. Output image, this is going to be optional as well. So here, guard let image data, let output image data dot output image, else we're going to just return nil. Then we can simply return the UI image passing output image. I think I should move this to a different file. I think just create C file, give it a name of models. Okay, let's import core image and import UI kit in here. Okay, it requires SwiftUI as well. Now in the view model, we can just declare observable macro and declare class view model. Okay, let's begin by declaring several vars first. First one is var try icon. Okay, so let's just initialize it with a sticker. So in here we just want the try icon. Okay, for the other props, it's going to be using default value we want to pass through in this case. Next one, let's declare stickers. This one will be an array representing the 30 stickers. Okay, so this will be an array of sticker. Here we can use this range operator 0 with this triple dot 29. So this will be 30 items. Okay, and then in here we're going just to map this. So here we can simply initialize the sticker, passing the position, which is the the index. Okay, now we have 30 stickers. Inside these stickers, this should be stickers. Okay, stickers plural. Okay, next one, let's say for a flag again, show original image false. This will be the toggle, like the one we use to toggle between the original and the background image, to toggle between the transparent and the one with the background image. Okay, and let's also declare this image helper, initialize it, the image vision helper. Next one, let's create this func remove image background. The input is going to be CI image and the output is going to be UI image optional. Here we can simply use guardlet masked image and then invoke image helper dot remove background from the input CI image crop to instant extents. We're going to crop this true. Okay, so in case it fails, we just return nil. And then if it succeed, we can simply return UI image CG image. Again, we need to invoke this image helper.render, convert this to CG image. Here we need to pass the masked image. Okay, so this masked image will be converted to the UI image. Now let's create a func that will be invoked when the user select item from the photo picker. Okay, so here func on input image selected. Okay, so we're going to have this image as the input CI image. This is the selected image, and we're going to also pass the sticker. Okay, so in here we can just declare input CI image. Let's just store this in a let, and then let input image just your image with the CG image. Here we need to convert this again to CG image, passing input CI image, and let output image. In here we need to just invoke self.remove matte background, passing the input CI image as well. And finally, let's copy the sticker struct. Okay, and now we need to mutate that sticker as well. Okay, first let's just declare the image data, initialize the image data. For the input image CI image, just pass the input CI image let, pass the input UI image here, and then the output image as well. This is also UI image. And now set sticker.state with selected, passing the image data or the shaded value. And now check if the sticker is tray icon. We can simply update the tray icon with the sticker. Okay, else we need to update the array stickers. We can use the sticker dot position to update it. Okay, so this is the one, the array. We're going to basically use this position to update the sticker. Okay, so this is the method for this view model. Now let's move on to implement the grid in the content view. Okay, let's navigate to, first let's navigate to the XCA sticker maker app, and here let's wrap this in a navigation stack. Okay, and let's go to the content view, the preview as well, wrap it in a navigation stack. Okay, now we can simply remove all of this. Okay, we're going to basically re-implement it with the grid. It's going to be a responsive grid, and it's going to be adapted to the container to display the number of items within a row. Okay, first let's declare a columns, an array of grid item. So to make this responsive, we're going to use grid item adaptive. Okay, for the minimum, we're just going to use the width, and for the maximum, the width. Okay, in case you're wondering which width is this, it is the one that we declare in the content view. So okay, so this is the minimum and the maximum, and then we're going to also add a spacing, passing that spacing let as well. Okay, now let's declare a state var VM and initialize it with the view model, and in the body let's declare a scroll view. Now let's begin implementing the scroll view. In here we can simply add a edge tag at the top. So at the top we're going to display the tray icon and the toggle. Let's add a padding of 32. And here we simply declare the image picker label. For the image picker, we're just going to use the image container view. For the batch text, passing IC try icon, and then in here we're going to check if the VM show original image is true. We're just going to show VM.try icon input image, else we're going to show the VM.try icon the removed background image, which is the output image. And next one, in the on selected image, we can simply invoke VM on input image selected, passing the image. For the sticker, we can pass the VM.try icon. Okay, now we have this image picker. Now we just simply declare the toggle, show original, and pass the is on binding with VM show original image. Nice. Now let's begin continuing on the edge tag. We need to use this LazyVGrid. Okay, so for this we can simply pass these columns. We can simply pass our column slot in here, and as well of the spacing for the content. We can simply use for each, passing the array, the stickers of array. It's already confirmed to identifiable. Okay, so in here I'm just going to copy and paste this and make some several modification. For the batch text, I can simply pass string, passing sticker dot POS plus 1. Remember that POS is using index 0, so we need to add the incremental 1. And for the image, in here we can simply change this VM.try icon with the sticker dot input image and sticker dot output image. Okay, in here as well we need to pass the sticker. Continuing on, let me check, is this the scroll view? Okay, so let's add a navigation title in here at the scroll view. Give it a title that you want. In this case, I'm just going to pass XJWA sticker maker, and I'm going to add a toolbar in here, passing toolbar item with the placement of primary action, and here I'm going to add a button with the title of export, and then in the closure itself to do send export to WhatsApp. Okay, we're going to implement the export to WhatsApp functionality a bit later. Okay, so that's it for our content view containing the main grid. Now let's try this using the Catalyst preview. Okay, let me bring the preview here. Nice. So we have the try icon and we have 30 stickers in here using that stickers array. So let's just quickly add image to test. Okay, this is a try icon. Maybe this one. So this one. Okay, everything looks good. We can play around with the toggle to show the original image or the image with the removed background. Okay, everything looks good. Now we simply need to implement to export to WhatsApp functionality. And for that, we need to read several of the WhatsApp guidelines on exporting the sticker. Okay, so this is the GitHub repository for the WhatsApp sticker guidelines. So if you see in here, I'll provide the link for this at description below. So first, I will just highlight the mandatory requirements. First, the sticker must be exactly 512 by 512 pixels, and sticker pack must have minimum of 3 stickers and maximum of 30 stickers. So that's why we declare that array with the 30 items, right? And it needs to have a try icon as well. And stickers must be either in PNG or the WebP format, okay? So we are not going to use animated sticker for this app, but if you see in here, each static sticker must be less than or equal to 100 kilobytes, and each animated sticker must be less than or equal to 100 kilobytes. So if we use the raw PNG file, the file size itself will be too big. So we need to basically have a mechanism to convert this PNG, raw PNG image file to WebP, which is more efficient in compression. So that will also have a reduced file size. And unfortunately, Apple doesn't support WebP natively in their framework, so we need to use Google libwebp, which is a library to basically decode and encode WebP format. Okay, so I've already created a SPM package that wraps that libwebp and the YY image that can be used to easily decode and encode WebP to UI image and vice versa. So we're going to basically use that. Okay, so this is tips for reducing file size, convert to WebP. So all of this, it's also providing the sample app, which I also use as a reference to create this application. Okay, so we need to provide several of the fields in here in our JSON when we send to export to the WhatsApp using the open URL. So we will implement this later. I won't go into detail explaining this, but you will see this in real example. Okay, so let's just go back to the Xcode and begin implementation. So now we are going to add an SPM package to help us convert our PNG data to WebP before we export that to WhatsApp. So click here and select this project and select package dependency, click plus, and basically this is the library that we're going to use, SwiftWebP. So this is a SwiftWebP decoder and encoder for UIKit UI image. So just provide these two main features, which is to encode UI image PNG to WebP data and to decode the WebP data to UI image. It's very simple to use as well. So basically it uses this Google libwebp, Xcode, and YY image under the hood for the implementation. You can check this GitHub repository as well. I'll provide the link in the description. Let me copy this, paste this, okay, save WebP, add the package. It's going to fetch everything, libwebp Xcode. Okay, so now let's just add this to our target. Okay, they are added now. Now we should be able to encode our PNG data to WebP before we export to WhatsApp. Now let's go to view modules to implement. So there are several constants that we need to declare in here. Let's just make this static let for simplicity. First one is passport sticker pack data type. So here we just need to provide net.whatsapp.third-party sticker hyphen pack. Okay, net.whatsapp third-party sticker hyphen pack. Okay, next one is private static let WhatsApp URL. Just initialize your string here. WhatsApp is the scheme, and then sticker and with the uppercase P. Okay, back. Just for some wrap this. And next one is private static let passport expiration seconds. Okay, this will be time interval seconds, which is 60. Okay, these are the constant. So let me double check this. WhatsApp sticker pack net.whatsapp.third-party sticker pack. Okay, looks good. Now let's create a new Swift file to help us playing around with UI image cropping. Okay, let's just give the name of UI image plus extension. So in here, just import UI kit and create an extension of UI image. So the first one we're going to create is this method scale to fit with the input of target size of CG size. And let's provide the default value of 512 by 512. So what this basically do is to basically resize a given image size, maintaining the aspect ratio, the scale to fit, given this target size that we pass. Okay, because if we don't scale this, when we crop the image to 512 by 512, if we don't handle the aspect ratio properly, the image will get squeezed, right? Because this is a square aspect ratio. So we have to basically handle this inside the scale to fit method. Okay, first one, let's determine the scale factor that preserves the aspect ratio. Declare width ratio. Target size.width divided by size.width. And size is the actual image width, right? And height ratio. Target size.height with the current image size.height. And let's define the scale factor using this min. Find the minimum, which one's the minimum between width ratio and the height ratio. Okay, so that will be the second scale factor. And then let's declare scale image size. Declare this CG size, width and height. For the width, we're going to use size.width multiply with the scale factor, and for the height, size.height multiply by the scale factor itself. So this will be the scale image size, which will be within the boundary of this target size, but will maintain the aspect ratio. Okay, now we need to render this. Let's create a renderer. Use this UI graphics image renderer. Okay, passing the target size, which will be this 512 by 512 by default. Okay, so that will be the renderer container. And let's declare let's scale image, and then invoke renderer.image. So this is the context. So in the context, we simply invoke self.draw in. Here we're going to pass the CG rect using this origin and size. So for the origin, let's pass so we need to find the origin that we want to begin drawing this sculpt image. Okay, so in this case, we're going to use this init xy. For the x, it's going to be the target size dot width minus scale image size dot width divided by 2.2. Okay, And for the y, target size dot height minus scaled image size dot height divided by 2.0. Okay, so that will be the origin where we are going to draw this, and the size is going to be the scaled image size. So this will should maintain the aspect ratio of the image in that 512 by 512 container. Okay, and now we can simply return the scaled image. Okay, next one is the scaled PNG data. So we need to basically also consider the current screen main scale ratio when converting the image to PNG data. So here we can simply invoke target size first, just initialize the CG size, width, height. Here for the width, we can use the width of the image divided by the current screen scale. Okay, same with the height, size dot height divided by the UI screen. Okay, so for example, for iPhone 13 Pro, it's going to be 3x, right? And some device will be 2x. I don't think we have iPhone with 1x scaling for now. Most of them are already having the Super Retina display, right, with 3x scaling. Now we just simply call the renderer again, UI graphics image renderer, passing the target size, and here we can simply invoke size renderer dot image. Okay, we don't need the context, we just invoke self draw in CGRAC origin just from the x0 y0, size is the target size, and now we can return the PNG data. Okay, let's just force unwrap. Okay, so this is the extension of a UI image that will help us to scale the image from the image that we have selected and we have removed the background for. So basically we need to scale it. We need to resize it to 512 by 512, maintain the aspect ratio correctly, draw it in here within this container 512 512, and when we convert to PNG data, we also consider the current scale of the device. Okay, we're going to divide that. Okay, this should be working now. We can simply now begin implementing the method to send to WhatsApp. Okay, so in here we simply declare this send to WhatsApp, and this is basically will be invoked in this button in the navigation toolbar, PM send to WhatsApp. And I want to also add a compute furnace here is able to export as stickers. Okay, so we're going to have this. So first let's get the stickers count, stuff.stickers filter. So the one that have the output image should be the one that has the image, right? We're going to count it. Okay, so remember that the maximum stickers is 30 and the minimum stickers is 3. Okay, but we don't need to worry about the maximum because we already initialized this with 30, right? So we only need to check the minimum. So basically the stickers that count must be equal to, sorry, greater than 2, and also the try icon dot output image is not nil. Okay, so with this we should be able to add a disabled modifier to this button. Disabled VM is able to export a striker, so add the negation. Okay, so when the VM is not able to export a striker, it's false, it's going to be disabled. Okay, now let's move on to the send to WhatsApp implementation. So first let's add a guard here, is able to export a stickers, true, and tray output image we grab this image data from the try icon dot output image. Okay, so if both fails, one of them fails, we just return. Okay, then we won't be able to export the stickers to WhatsApp. Now let's continue. First one, let's sticker let output image tray data. Okay, in here we use the try output image and then invoke scale to fit target size. And for the try icon, the size must be 96 by 96 instead of 512 by 512. Okay, so after we scale that, we just need to convert that to the scale PNG data. Okay, we got the scale PNG data. Now let's just add a debug const print tray byte size just for debugging. Okay, remember the image must be under 100 kilobytes, right? Okay, count. Okay, now continuing on, we need to declare a JSON string any here. First one is the key for identifier, so you need to provide your identifier. This should be unique, so I'm just going to use XCID for me, but for you can provide your own unique value. And next one is JSON name. Okay, I'm just going to hardcode this to XCA, but if you want, you can also add text field in the UI, right, for the name and the publisher that you can input, and then you can basically use that value from the text field to assign this to the name in here. So this will be basically shown in the WhatsApp application, the sticker name as well as the publisher, the author of the sticker. Okay, so you can provide your own value if you want. Publisher, I'm just going to give my name Alvin Losari, and try image. This will contain the best 64 encoded string of our output image tray data. So this is the PNG, and then we need to call this best 64 encoded string. Okay, continuing on, let's declare the stickers array. So this will be an array of dictionary any. Let's initialize this with empty array. Now let's just declare let stickers image. We need to basically get the sticker with the output image exist using the compact map. Here we just get this image data and the output image. It will basically filter out the image data which doesn't have the output image. Okay, now we can simply loop this using for image in stickers image. Okay, so here let's declare our stickers dictionary string any, and let's declare the output PNG data using image dot scale to fit. Okay, remember the default value is already 512 by 512, but we can also pass this explicitly in here. Okay, this is for the sticker requirement, and just invoke scale PNG data, and then we can also add the debug print in here, stacker size output PNG data dot count. Okay, that's the bytes count. And now we need to check if let image data. So to fit the 100 kilobyte limitation, we need to basically convert this to WebP, which provide a lower file size compared to PNG, right? So we need to import SwiftWebP SPM package, right? And here we can just simply initialize this WebP encoder and invoke this encode PNG, passing the PNG data, which is the output PNG data. Okay, so basically that will return optional, so that's why we use if let. Here we need to initialize this sticker stick, assigns this image data with image data. Okay, this is WebP data, and invoke best 64 encoded string. And we can also set our sticker with emojis, array of emojis. But in this case, I'm just going to hardcode the emoji. Okay, so this one. But you can actually associate a sticker with an emoji, array of emoji. Okay, now I can simply append this stickers array, append passing this stickers dictionary. Okay, so after this loops complete, we can assign this JSON's stickers with the stickers array. Okay, continuing on, let's declare this var JSON with App Store link. I'm not actually sure what this is, but let's just follow the convention. Okay, JSON with App Store link. It's going to be iOS underscore app underscore link. Let's just provide an empty string. And next one is Android underscore play underscore link. Maybe you can associate the sticker with the App Store, with the app that used to create this. Not sure. Next one is this guard let data to send. We need to convert this using JSON serialization to binary data with JSON object, passing the JSON with App Store link. For options, just pass empty array. If it fails to convert to buffer, we just return. Continuing on, let's declare let passport and grab the UI passport, the general. So we need to basically use this UI passport to set the items. Okay, this should be an array of dictionary. So first one is the view model dot passport sticker pack data type. So in here, we're going to pass the binary data containing our stickers. Next one is this options. Okay, for options we need to pass this UI passport dot options key dot local only. So we need to pass through in here. And another one is UI passport dot options key dot expiration date. In here we need to pass ns date. You can pass date time interval since now. Can pass view model dot passport expiration seconds. Okay, so a bit complicated. Maybe I need to clean this a bit to make this more readable. Okay, so we have set the items to the UI passport, and now we can basically check if UI application. So first, let's just to make sure we are accessing the US application in the main thread. Just use dispatch queue main async. Okay, because if we access this UI application in background thread, it will crash the app, right? So here we can basically check if UI application shared can open URL. So the URL will be WhatsApp. Okay, scheme. Let's just first unwrap this. Only if this is true, we are going to invoke UI application shared open view model dot WhatsApp URL. Okay, so this is our the WhatsApp URL, WhatsApp sticker pack. Remember that to make this successfully, can open URL, you need to add the ls squared scheme WhatsApp in the info plist. Okay, so now we should be able to try this. But to try this, exporting to WhatsApp, make sure you have your iPhone device and you have installed WhatsApp as well there. Now let me select my iPhone here from the scheme and run this. Okay, we succeeded. Let's see. I have set up the QuickTime mirroring as well. Now let's select the icon. This will be the icon. And let's add 3 stickers at least. Maybe add 4. Click export. Okay, Xia, we are sticker maker wants to open WhatsApp. Importing sticker pack. Nice. We got the 4 stickers. Let's save this. Okay, now let's open the tray. Nice, we have this tray icon. So it's me with the red shirt. And this is the 4 stickers. Nice. Amazing. So it works. So amazing, it works. So one thing that you can improve is maybe you can also add a progress indicator when we performing the background removal. Maybe you can start it in a background thread instead of main thread, as well as when we processing the image to be imported to WhatsApp. Because right now I haven't managed that loading state, right? Also, we can improve the main thread by just moving all those process to background thread when we are processing with the image, as well as exporting to WhatsApp. Okay, so there's are several things that you can improve. Actually, with this as the base, there's a lot of possibility you can use to create your own sticker application. So maybe if you want to also import the sticker to iMessage, you can also use this as the basis, right? So yeah, I hope you like this tutorial because I sure learn a lot of things when I implementing this. And now with the subject lifting API from the Vision in iOS 17, it's very easy to basically manipulate image, manipulate subjects, foreground objects. Okay, so that's it for this quick video maybe. So love it. So like it if you like it, subscribe if you haven't to this XCA channel, and thank you for supporting me so far, and until the next one, keep on being a lifelong learner. Goodbye.